Hello friends. Now in previous video we have studied a technique how to solve a numericals related to solutions of differential equation or a differential equation Laplace transform. Now we are going to solve a numerical based on the same. So we'll study a first numerical of solutions of differential equation. So the question is problem number 1. A continuous time system is described by a differential equation and the equation is given y double dash of t plus 5y dash of t plus 6y of t equal to x of t. And what is asked? Determine first of all transfer function. Now as I told you, while calculating transfer function or while calculating, next one is a step response and third one is impulse response. While calculating all these result, we have to assume initial conditions are 0. So don't bother about initial conditions. But in this video, I'm going to tell you the basic formula and which term you have to ignore, that I'll also tell you. So the much more important one is how to find out transfer function. And then after that, these two parts is dependent on it. So let's go through the solution first. The question, y double dash of t plus y dash of t plus 6y of t plus x of t. This was the question. Now here we have y double dash of t as well as y dash of t. Now what is asked? They have asked to find out first of all transfer function, second is step response and third one is impulse response. But to find out all the results, first of all what we are going to do, we are going to apply Laplace transform on this equation and we are going to assume all the initial conditions are 0. Now if we apply Laplace transform y double dash of t, then result is of course this you will get. Similarly, if we apply Laplace transform y dash of t, then this will be the result, and the Laplace transform y of t and x of t is y of s and x of s respectively. But what I'm going to write next is we are going to assume initial conditions are 0. If initial conditions are 0, which means these terms are considered as 0. Now while going for solution, you can write this whole formula, but before writing just mention applying Laplace transform and then write this whole formula. Then after that just write we are going to assume initial conditions are 0. So in the next step only write s square plus y of s and sy of s only. But my suggestion is don't waste your time, just directly write apply Laplace transform on both this side and assume all the initial conditions are 0. So only this part you have to write. So I'm doing the same thing. So look at here. So applying Laplace transform both these sides, what we will get? Laplace transform y double dash of t plus 5 is the constant, that's why I've taken outside. Laplace transform y dash of t, then 6 is a constant, Laplace transform y of t, and the last one is x of t. Now, as I told you, after applying Laplace transform both these sides, what I'm going to do? I'm going to assume all the initial conditions are 0. So if we assume all the initial conditions are 0, so I'm not going to write this s y of 0, y dash of 0 and y of 0 in my solution. I'm going to write only the differentiation part or the Laplace transform differentiation, which is for y double dash of t, Laplace transform s square is y of s. Next we have plus into 5. Then Laplace transform y dash of t, Laplace transform y dash of t is sy of s. Then 6, Laplace transform y of t is nothing but y of s equal to Laplace transform x of t is nothing but my x of s. Now what I want, the first question is find a transfer function, and for transfer function what we want? The Laplace transform output, basically a ratio of Laplace transform output upon Laplace transform input. Now here we already have the output response which is in Laplace transform, that is y of s is mentioned or written on the left hand side, and on right hand side we have got the Laplace transform input. So if I take y of s common from the left hand side, and the whatever constant will be there, we'll shift it on right hand side, and the x of s will take it on left hand side, then automatically you will get the transfer function. So I have taken y of s common from the left hand side, so we have got this equation s square plus 5s plus 6 into y of s equal to x of s. Now, if I take the ratio of y of s by x of s, then it is nothing but my transfer function and it is represented by h of s. And my equation will be, if I shift this x of s on left hand side and if I coefficient is shifted on right hand side, then this coefficient will be in the denominator side. So we have 1 upon 5s plus 6, and this is our solution of first part. So I'm going to write this one is my transfer function. Now the second part was step response. How to find out step response? As I told you, step response means what? First of all, we have to assume my x of t is my unit step, and the Laplace transform of x of t is nothing but Laplace transform of unit step, and it is nothing but u of s. So my answer is, so what is our next step? This will be my equation number 1. So from equation number 1, what I'm going to write? What is the next step? I'm going to multiply this x of s on the right hand side. And what is the value of x of s? It is nothing but 1 by s. So my y of s become 1 by s upon s square plus 5s plus 6. Now I'll take this 1 by s in the denominator. Now, what I've done? To find out a step response, what is the first step? You have to assume my x of t is unit step and then go for the Laplace transform of it. Then we will get the result. Now shift the equation number 1. Look at it, equation number. We have y of s by x of s. So shift this x of s on left or right hand side. Or you can say multiply x of s on right hand side. So after multiplying, substitute the value of Laplace transform of input, and my input was unit step, so unit step value was substituted, and then what I've got, this is the result. And if I take the inverse Laplace transform of this y of s, then result is y of t, and it is nothing but my step response. Reason why it is a step response? Because I have substituted my input as a unit step. If you substitute input as a del of t, then that response becomes as impulse response. I'll tell you in next part solution, but right now the step response is important. So what is the next step? How to find out y of t? So first of all, find out the factors and then go for partial fraction. Look at it, the last part is product of two digits, which is 3 into 2 is 6, and if we add the same 2, then you will get the 5. So my factors are s plus 3 and s plus 2. So now we have 3 poles or 3 factors, then we'll use 3 different variables. And this is nothing but my equation number 2. Now what is the next step? Simply multiply this left hand side on the right hand side, or denominator part on left and right hand side. What you will get? As I told you, the shortcut, just ignore this s, or just don't bother about x. Only these two will be multiplied with a. Now on the left hand side of denominator, here we have b, and in denominator of b we have s plus 2. So exclude this s plus 2 part and multiply the rest of the part with a b. That is s into s plus 3 will multiply with a b. Now the last one is a c. In the denominator we have a s plus 3, so remove this s plus 3 part and just multiply the remaining term, which is s into s plus 2. Now how to find out the variables a, b, c? Just substitute the values or equate the values of s which is placed in the denominator. Now here we have denominator. In the denominator of a we have s, so equate it with a 0. So we are going to substitute s equals to 0 to find out the value of a. So if I substitute s equals 0 in equation number a, what we'll get? On the left hand side we have only 1. All this s is replaced by 0. This 2s is replaced by 0, so whole product becomes 0. So I'm going to write it by, replace it by 0. Now 2 into 3 becomes 6. So we have 1 equal to a into 6. So therefore my a value is 1 by 6. Similarly, we'll find out the values of b and c one by one. Now, what we have to do, we have to find out the value of b. So, which term is missing over here? S plus 2. And if I substitute opposite value of 2, which is minus 2, in the place of s, then automatically this a and c value become 0. So we'll substitute s equals to minus 2. This was our equation number 3. So what you will get? On the left hand side we have 1. Now minus 2, if I replace this as by minus 2, minus 2 plus 2 becomes 0. So whole product becomes 0. Now inside of b, here the s is replaced by minus 2. This is also carries the same value. Now look at here, minus 2 plus 2 becomes 0. So see, this c value also becomes 0. So 3 minus 2 is 1 and 1 into minus 2 is minus 2. So we have minus 2b. So if I shift this minus 2 on left hand side, what you will get? Minus half or minus 1 by 2. So my b value is minus half. Now we'll move on to next, that is c. Which term is missing over here? The s plus 3. So equate this s plus 3 equal to 0. What you will get? S equals to minus 3. And if I substitute s equals to minus 3 over here and here, then automatically b and a value becomes 0. You will get only the value of c. So this s is replaced by minus 3. This is also replaced by minus 3. Now minus 3 plus 2 is minus 1 and minus 1 into minus 3 is plus 3. So we have 3c. Now if I shift this 3 on left hand side, what you will get? Your c value is now 1 by 3. Now what is the next step? Now substitute all the values of a, b, c in my equation number 2. So you will get the step response. So I've substituted all the values of a, b, c in my equation number 2. So this was the result. Now what is the next step? Simply apply inverse Laplace transform. So applying inverse Laplace transform, what you will get? This y of s inverse Laplace is y of t. Now 1 by 6 is a constant and the 1 by s is nothing but u of t, because the input which is applied is unit step. Next, the half is a constant and we have 1 upon s plus 2. If the s is shifted by 2, then of course we will use a frequency shifting property and multiply this t value by the opposite sign value of plus 2. It is minus 2. So answer is e to the power minus 2t. Now this plus 2 is removed. So what we have? 1 by s, and 1 by s is nothing but unit step. In the next part, I will take 1 by 3 common. Again, we have a s plus 3. So what is the result? Multiply this 3 by opposite sign value of plus 3 is minus 3, and we have 1 by s is left, and it is nothing but unit step. Now, if you want, then you can take unit step common. And this is nothing but the result of step response. Now, we'll move on to last one, which is impulse response. Now, what is important in impulse response? You have to assume your input is an impulse function, that is a del of t. And the Laplace transform, if you apply Laplace transform both the sides, then you know that we have studied the Laplace transform of del of t in the pre-videos of elementary signals of Laplace transform. What is the result? The del of t in any type of transformation, the del of t always gives the value 1, which means the Laplace transform of x of s is 1. From equation number 1, what was the equation? Y of s by x of s. This was the equation. Now multiply x of s on the right hand side. What you will get? Now substitute your x of s value and it is 1. Now your transformation is ready to convert into impulse response. But before of that, we have to find out a partial fraction. So first of all, the factors. The factors are 3 into 2 is 6 and 3 plus 2 is 5. So these are the my factors, and we have a two factors, which means we'll use a two values, that is a and b. And this is nothing but my equation number 4. Now multiply, just do the cross multiplication. So as I told you, the shortcut one, what is there in denominator of a? We have s plus 2, so ignore this s plus 2, only s plus 3 will be multiplied with the a. And in case of b, here we have a s plus 3 in the denominator, so b will be multiplied with the s plus 2. This will be on the right hand side, and then left hand side we have only a 1. So this is my equation number 5. What is the next step? Substitute s equals to minus 3. In equation 5, what you will get? On left hand side we have 1, but this s is replaced by minus 3, so whole bracket will give us 0, so 0 into a becomes 0, so we have a 0 over here. And minus 3 plus 2, answer is minus 1, so we have minus 1 inside this bracket. So what you will get? 1 equals to minus b. Therefore if I multiply minus sign on both the sides, our b value is minus 1. Similarly, do the same thing with the for a also. What I'm going to do, I'm going to substitute s equals to minus 2 in equation number 5, because if I substitute s equals to minus 2, then this b bracket will become 0 and you will get only value of a. So 3 minus 2 is 1, so a into 1 is become a, so we have a value which is 1. Now substitute all the values of a and b in my equation number 4. What you will get? This is my equation. Now what is the next step? If we apply Laplace transform, then the result, whatever result will be there, it is in the form of impulse response. So let's see. Now what is important? We have to find out the impulse response, but before moving to impulse response, we have to find out, apply a inverse Laplace transform both the sides. What you will get? The y of s inverse Laplace transform is y of t, whereas 1 is the constant, so leave it. 1 upon s plus 2 we have, so s is shifted by plus 2, which means we have to multiply this t by opposite sign value of plus 2, which is minus 2, into 1 by s is nothing but unit step. Why I have written unit step? Because 1 by s is the response of unit step. We have applied a del of t as an input. Now why I have taken a del of t as an input? Because in question it is mentioned impulse response, but while calculating inverse response, what I'm going to place here? U of t. Why not del of t? Reason is, at the end, after removing plus 2, what is remaining over there? That is 1 by s. So the 1 by s inverse Laplace transform u of t, but we cannot write del of t for 1 by s, because unit step response gives us a Laplace transform, that is 1 by s. So if you apply del of t as an input, then also your result will carry a unit step response or u of t value. Now we'll move on to next. We have a minus sign, and then 1 upon s plus 3. Once again we will use a frequency shifting property, so minus 3 we multiplied with the t, and the last one is 1 by s, and it is nothing but the unit step response. Now you can take u of t common. and this is nothing but your result. So that's all for now. First three numericals are completely based on a transfer function, impulse response, and the unit step response or simply step response. But the next three numericals, that is problem number 4, 5, 6, is based on total response, zero state response, and ZIR, that is zero input response. So stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.